All right. So with the with going with this actual RHCSA to infrastructure engineer, you can substitute RHCSA with an LPI certification or the LFCS certification um, inside of this. So don't get stuck on just Linux administration from a Red Hat perspective, but also understand it can be substituted. Okay, so what's the reason for the Linux certification? Well, your Linux certification is really in my eye, or in or even understanding Linux in my eye is the roadmap to, and there is a map down here. Um, it is the map to really that's too big. It is really the map to where you want to be in terms of your certification and certain not just your certification, but in terms of baselines of working with um, infrastructure engineering, Kubernetes, Terraform, or anything that you really see out in the cloud domain. Windows is still a thing. It's still people still use Windows in the cloud, but most of your servers that you'll see are probably Ubuntu based or Debian based or Red Hat based or CentOS, I should say. Their SUSE is still around. Let me type that out. They have their own certification too, but it's SUSE Linux is actually still around. Not as big industry wise, being utilized a little bit more, I guess you could say boutique, if that's the right way to describe it. You still find jobs, but it's a little bit more boutique. So with this roadmap and this particular link here, I kind of went through like job opportunities, and then breaking down automation, security, cloud, VMware. uh, I could have left this as a VCS, version control system, VCS version control system, but the one I chose was GitLab. Tech leadership, again here certifications, command line fundamentals, and then a career path. So I think it's still relevant. I need to update this because I need to add on some more stuff. But again, I think this is like just your basic of what you would need to get started and be on your way within the next. I saw a cloud computing class, they're doing 24 weeks. So you could do this in really, that's about right, 24 weeks. What's that for? Yeah, 6 weeks. Six, is that six? No, 6 months. So 6 months you could do all these things and be ready to go in 6 months. So what does that mean once you do these things in 6 months? In 6 months you could be anywhere, um going anywhere from um 80,000 to uh, 300,000, depending on how aggressive you are, in terms of jobs, in terms of freelancing, in terms of being on a team or what have you. Is there any questions so far before I kind of dive into some stuff here? You're free to ask questions, by the way. No? Okay. All right. So,
Actually, I'm sorry.
okay.
I
Go
do have
ahead.
a question. Okay,
Okay.
so are you saying 6 months to get all of this information?
Yeah,
Um,
I feel like you could do, so I feel like you could take, and this depending on how aggressive you are, because I know some people that'll sit down and take and study something for a week or two and then go take a test based upon memorization. Don't necessarily mean that they actually understand everything, but they knew enough to pass the certification exam. So what does that mean if I go to apply for a job? Well, they're gonna look at it and say, "Well, you're Terraform certified." Well, okay, cool. Let me see what you know. Maybe you know enough, or maybe you don't, but you've passed the test. So I don't feel the need to test you. Some people do, some people don't.
mhm.
It's a gamble.
Okay. So, but you're talking about getting certified or doing certifications
Hmm.
for these different technologies within the
Right.
next. Right. I gotcha.
R-
Okay.
Right, right. So my basics are this, and I think it may be on here. Let me just go back to it without going through everything. My basics are when it comes to the Red Hat certification and just infrastructure engineering altogether is Linux certification, Security Plus, understanding a version control system, which would be right now GitHub or GitLab. Most people are aiming towards GitHub. And then the next one is understanding some type of configuration management tool, whether that is Ansible, and I have this on there, but I just want you to see what that symbol looks like. Ansible, and then I'll pull up this other guy, Ansible. Let's see, where is it at? Ansible, Puppet, and Chef are the three. So there is a roadmap out there called roadmap.sh here, and they have one for DevOps. So they have one here just like that. And they give you pretty much an overview of things to learn. Not that you got to do it, but like here they have say some personal recommendations. So pick one of these. Python, it will be my go-to. Some people go to is Node.js for applications. Here, this right here all falls under understanding Linux and OS concepts. You would get all of this out of a Linux class. So that takes care of that. You would get all of this out of a Linux class. You would get this and this out of a Linux class. Screen comes out of Linux. Tmux can be utilized on Linux. There's a Tmux terminal, but then down here, they like they say, learn an operating system recommendation Linux, and then they fall into RHEL, CentOS, Ubuntu, Fedora, Debian, and SUSE, all the things that I named. And then this OSI model is just OSI model and DNS, understanding networking. It's always something that you're gonna need. It's no way around networking. Without networking, we wouldn't be sitting on the phone.
Right.
uh you know so here they have the networking and security protocols. As you start playing with Linux and installing application, you're going to start playing with networking, you're going to start playing with security, you're going to start playing with protocols, being it TCP and TCP and UDP. You'll start playing with that. So again, all of this, you use this every single day. Everybody goes to a website and it's either HTTP or HTTPS. Just something that you do. You use email. You see, you if you ever set up email on your phone or or on your laptop, you've had to find out what the IMAP or the POP3 server is, or SMTP. You've had to use that. That's just something that you had to do. Um, Unless you just use the web browser and just log in. And then here, when it comes down to web servers, this layer right here is the new layer. This is the new stuff. And then over here is old stuff. So IIS refers to Windows. Nginx, in reference to Nginx, would be your front end, along with Apache, Tomcat, and Caddy. I've never used Caddy. I can tell you that. And then here they have again learning basic scripting. This is going to go on any Linux system, any Windows system with PowerShell. These are common tools, awk, set, grep, sort that are just basic tools on your Linux boxes that you'll use. And then here we go. Now it's time to learn infrastructure as code. So remember, I was talking about a VCS, your version control system with GitLab CI, Jenkins, Travis, Concourse, Circle CI. And then here you have your Ansible, Chef, Salt, and Puppet. And then they got container orchestration, where we'll start talking about Kubernetes and Nomad. The two hot ones right here, these two uh, are dying. you'll find Swarm and smaller places. Mesos, I think, got bought by Red Hat, and Red Hat is now killing that project. So really, these two are your two hotness right now. Um, Again, infrastructure provisioning, Terraform Cloud and Pulumi. Never played with it. Couldn't even tell you about it. Won't lie on that, but we can always learn and look it up. Prometheus, uh, all these are considered monitoring tools. Easiest one to probably learn right now, like if you just want to play with it, would probably be Datadog and Zabbix. Zabbix is just, hey, I have an agent over here, I have a server over here. These two can talk to each other, and I can go monitor my stuff. I'll pull up Zabbix in a minute. um, New Relic, and we're here again. Now we're talking about application monitoring, infrastructure monitoring, meaning we're talking about the actual system itself, the actual your actual laptop, your actual server, your actual EC2 instance. That's what we're monitoring, and then we'll throw an application on top of that hardware. And now we're going to talk about application monitoring from that perspective. And guess what? Everything you do creates logs. So if you can imagine how many logs a day that Google gets, or how many logs a day your router itself at home gets, so everybody in the house, if you put your phone on there, if you put your on your Wi-Fi, if you put your laptop, your tablet, your TV, you can imagine how many log files you get a day, or how many times your logs get written to on your internet. I mean, on your router. And then here they talk about cloud design patterns, and we'll get into that later. Again, cloud providers. They left out AWS, but DigitalOcean is one that I use. Linode and Volter. I've never heard of them. And then uh, as far as the design patterns, here we're talking about.
Actually, for cloud providers, they've got that. You look up
Oh,
on
okay, I see. Okay,
the,
yeah, I see that
because I
one
was
up
going to be
there.
like, oh, this is irrelevant.
Yeah, well, yeah, AWS, Azure, Heroku, Alabama Cloud, that would be China. Heroku is, I think they're statewide. I think they're on the state side, I think. And then availability, data management. Um, think when you think data management, think about where is your data stored in terms of your personal information, data encryption in motion and data encryption at rest, and then how much data is generated by just your household, and what does that look like? And design and implementation, we're talking about architecture here. And then management and monitoring still goes back under these two, but they're still management of managing the infrastructure, uh, that, well, I said the SLA or the agreement that you have with AWS or whatever cloud provider there, and then whoever else is using your cloud account. There's still some monitoring management to that. Any questions there? I know it's a lot. Don't feel bad. It's recorded, but I just need to know that everybody kind of got some ideas, or did you have some questions?
I have a
Silence is
question.
okay.
In terms of AWS versus Azure, do you recommend one over the other? It seems that
Mm,
AWS is more, I don't know, it appears to be more widely used, perhaps.
I mean, they're the biggest. They're the biggest one being used. Do I recommend one over the other? I'll say this. I think Azure and Oracle were offering free classes, and I think so was Google. So if you got a chance to take them for free, take it and get certified on them. Do I recommend one over the other one? Of course, AWS will probably be the default one, but it also is company dependent because not everybody else uses Azure. I give you, has anybody ever heard of Ashley Furniture?
Yeah, they were in Texas. Yeah.
Okay.
Yep.
So I was on a meetup with them last week, last Tuesday, Um, they don't use AWS. Do you know why they don't use AWS? Just a wild guess, anybody.
I have no idea.
Okay.
Don't
So
know.
the reason why Ashley Furniture doesn't use AWS is because they look at AWS as their competition. Does anybody understand why?
Oh, because
Oh,
Amazon sells
and
furniture and
products.
Exactly.
oh yeah.
Exactly. So it could be that it's company dependent on who you are interviewing with. Some people are really strong on AWS. Some people are migrating from AWS to Azure. Some people are going to Google Cloud. It really depends. Zoom is on Oracle Cloud. I think Oracle Cloud got the account for Zoom. So for
And it was for
me,
that same reason of Oracle not being OCI not being a direct competitor to
exactly.
Zoom. Yeah.
Exactly. Exactly. So when you ask that question, I'm going to tell you those answers, but I'm going to also say play with every last one of them. Create account, log in, play with the console, and this is how I did it. This is how I learned, and go with what you're comfortable with. If you feel really 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 comfortable logging in and playing with AWS and all of it makes sense to you, then start down that path. If you feel really really comfortable playing with Google Cloud, then start down that path. And the only reason why I say that is because there's jobs out there across all those fronts. Of course, AWS is going to probably have, you'll probably find more, but you'll find just as much with Azure as you probably will with AWS.
Okay. Okay.
I hope that made sense to you, didn't confuse you.
Yeah, thank you.
You're welcome. All right. So we are going to start tonight with some basics. And where is my configuration stuff? Right here. We are going to start right here. Infrastructure provisioning. And we're going to start with some basics of Terraform. And I posted the link, and that link is the first link. I posted it again in case somebody came after I posted it. I think no one did. Hey D, can you post the link? Because now I can't post it.
Which link for the Untitled
Terraform.
Terraform? Okay, give me a minute. I'm gonna get that.
I posted in Slack just in case we have some people in Slack. For whatever reason, my screen does this crazy thing. Set it over. There you go. All right. So, infrastructure as code. All right. So let me do this. I want to go to DigitalOcean. Where is my login? There it is over there. Cool, cool, cool. Droplets. Let's change projects. Okay. So, infrastructure as code. What that truly, truly, truly means, and let's get over here. That's what is Terraform. We're not going to tell you what Terraform is. We're going to say infrastructure as code is a person, or it could be a thing, it could be AI writing the code, but basically it is a way for me to take my infrastructure and codify it. Basically, and let me give you what I'm talking about here. Basically, I'm taking my infrastructure and I'm writing it out as code. So I am going to write out all my infrastructure that I have, and I'm going to put it in here as code. What does that mean for me? Well, let's look at that. And what does that mean for the team? Well, it means a couple of things. It means now I'm able to write my code I'm able to version control my code. That's one. I'm also able to take my code and not only version control it, I can share my code so I can have multiple people working on this code and submitting their changes to a version control system. It also means that I'm able to uh, know what I have. So, what does that mean to you? So, I just logged into my DigitalOcean account. Now, if I wanted to know how many servers I had spun up at this particular time, and I didn't have my infrastructure written as code, I would have to log in here and see what I have. But because we have APIs now, and we have Terraform and Ansible and all these other tools, I can query my account out at DigitalOcean and get back what I have. So I don't have to use Terraform, but I'm gonna tell you why you should. I can use DigitalOcean has a command line tool called DOCTL, DigitalOcean Control. Here's their command line. I guess you could say DigitalOcean command line. They have this tool that you can download and install, and they tell you, hey, I can come in and query for accounts and databases and Kubernetes and things like that. I can even deploy instances with DLTCL. What I don't get, and the advantage that I get with using Terraform is I'm gonna call Tara on this one. She should know. What is my advantage that I get with using Terraform?
You're able to use multiple technologies. So right now you're on DO. If you decided to go to AWS or whatever, you'd Terraform, it would be no big deal. Whereas with DigitalOcean, you would have to completely redo it. The other thing too is that it's Terraform is that the one that's state
Yes.
stateful?
Wow. That's what I'm talking about. Come through with the knowledge. Come through with the knowledge.
Unleaded gas.
Come through with the knowledge.
Oh,
That's what
I
I'm
am not on it.
Yes. And that's and that's the truth. So what Tara is talking about, and when she gave me the right answer. Okay. So when we talk about having state, so here back in. Okay. So when we talk about having state, we're talking about I have a way to actually query what I have inside of AWS or VMware or wherever I'm holding my state file at. What advantage that gives me is if I have my state file centralized, say I give this project to Tara and I give the project over to D, and I give the project over to James, and they both started, all three of y'all started using this particular project. And you say, well, I wonder if Tamika deployed uh, the satellite server, and where did she deploy that to? You could query the state. You don't need to call me at 3 o'clock in the morning to ask me that. You don't need to hop on the phone with me to have a quick conversation to ask me that. You can already utilize that and you will already know that because you could query the state. And the other advantage is, I'm going to promote GitLab right now, is you can create comments inside of GitLab. So I don't know if people are familiar with Jira and Confluence and so forth. So you can use GitLab as your all-in-one for everything that you need, which is totally cool because now you can say, okay, I don't have to have all these other things. And when I'm talking about this, I'm actually literally talking about you can set up static pages. You can treat it as you're just you just want to keep notes and so forth. You can do that with your code, and you can do that here with um with GitLab. If you need a web IDE, you can hop over here and you can treat it like an IDE. So I can come in here and I can, get my little lines and do my little edits and so forth and everything else. So just a FYI. All right. So you answered the question, state file. And she was actually correct with the fact that it is also able to go against multiple uh, um, cloud providers. So let's talk about that. So with Terraform, say I'm out in AWS, right? And I do a deployment, but I wrote all my code in cloud formation to deploy to AWS. I can't take that same code uh, in cloud formation and port it back over here to Terraform. I can take the output of cloud formation if it's outputted in JSON. I can take that and I can use that inside of Terraform, but I can't write it in cloud formation code and utilize that with Terraform. I can take Terraform, I can write up some modules, or I can I can use resources and write that up in Terraform, and I can use that over here. And I'll show you some of that code. We're about to get into that. The same thing with DigitalOcean. I can't take DigitalOcean command line tool and then deploy to uh, AWS. Not without some hoops. It's just not natively where it's talking to. It's natively talking to DigitalOcean. 1 second, let me get D this so she can send somebody's trying to get in. All right. So with that being said, let me show you go back here. Some infrastructure as code. I'm gonna just show you the infrastructure as code and then I'll back out. So let's go here. We're hopping into Terraform here. That project's a big project. Let me go to my projects. Let's look at an easy project. Mm, this may be a good one. Yeah, right here. Yeah, that works. Okay, we'll go there. All right, so basically, and the reason why I'm showing you this stuff this way, there is, let me give you this. So there is an exam that we're working towards learning. So someone asked about Azure or AWS. You can use Terraform to learn AWS and to learn Azure. So I'll put this out there. Let me see. It's not letting me do it. I'll post it and let D post it for you. Okay. So what I'm able to do, did it come back? Nope. Nope. So what I'm able to do is with Terraform is I can go here, I can start deploying out to AWS, Azure, Google Cloud. That state information we were talking about, that's what Terraform Cloud does. And then managing with Terraform, you can deploy a Kubernetes cluster with Terraform, and then they get into prepare for the exam. And then here is their exam guide that they have. Basically, they talk about what we're starting off with right here tonight is what is infrastructure as code? What does it look like to be in a private cloud, meaning on-prem, meaning I have servers sitting in my server room and I'm doing a deployment. 9 times out of 10, it would be something like OpenStack or VMware that you're utilizing to do a deployment in a private cloud. You could have AWS Outpost and Azure Stack as well, but those are a little bit more costly than any other thing. And then it talks about the documentation and then Terraform use cases. So tonight we're going to cover this learn infrastructure as code. We're going to start getting into what providers are and managing your infrastructure, which we talked about, and then we'll do a little something with the workflow. We don't have no choice. So that's gonna cover tonight, and then I'm every week I'm gonna reiterate over these concepts so that you have them in your head, you understand them, they're not foreign to you. So let's get over here. All right, so they asked what is Terraform. Well, how easy is it to install Terraform? You come over here to the download section. You pick whether or not you're on a Mac or you're on a Linux box or a Windows box. And it's just it's a binary that gets installed. Usually what I try to do, let's clear this. I try to throw mine in user local bin. And then let's grab for Terraform. So there we have it. There's Terraform right there, installed right there, and also TerraGrunt. We'll get into that after we do Terraform stuff. All right, so that's it. You download it. You unzip the file. You drop it over into a binary or drop it into a path where your system recognizes it. And is this too small, by the way? Make this.
It's a little small, but okay. So and then you should download it into. Is it recommended to just do it in your Linux?
If you have a Windows box, you can put it in Windows. If you have
I have a Kali.
you have what now?
Kali.
Yeah, so just download. It should be 64-bit. If I just click on this, it's gonna start downloading,
Okay.
and then it's gonna download a zip file, and then that you unzip that file, and take it and put it in user local bin.
Okay.
And then once you do that, Terraform is installed. All right. And this is recorded, so if you're not keeping up right now, it's okay. Try to make that bigger. All right. So how do I know Terraform is installed? Well, I can do Terraform help, if I spell it right. I can also do Terraform dash help. Does that work? Yep. And I can also do Terraform -H. See? So I know Terraform is installed. And to double verify that, I can echo $path, and I can see that user local bin is in my path. So therefore, I know Terraform is in my path. Therefore, I'm able to do this. Terraform. All right. So we have Terraform installed. All right. So they go over what infrastructure is called. I read it out loud. Infrastructure is described using a high-level configuration syntax that allows a blueprint of your data center, or in this case, your infrastructure, to be versioned and to treat it as you would any other code. So if you're writing Node.js, if you're writing in Ansible, if you're writing in Java, if you're writing in Python, you want to use Git to send it to a version control system, or I should say something like GitLab, so that you can, if you make changes to your code, you can keep up with those changes and so forth. There are execution plans, and then there's also a resource graph, and then also change automation. So in other words, if I make a change to my code, once I check it back in, like you say here it says complex change sets can be applied to your infrastructure with minimum human interaction, which is true. Basically, if I make a change in any of this code and I check it back in from command line, usually you want to do command line, it's going to come through and it's going to analyze should I make those changes or not. and then do a deployment. Any questions so far? Oh, okay. Oh, we're on the wrong thing. Oh, where was my little link at? Sorry, missed my link. No, that ain't it. Let's go to intro. Yep, here we go. All right, so they give what some use cases are. We saw on that road to DevOps down here where they start talking about Heroku, and that's what they're talking about here, how to set up an application, doing multi-tier applications. So let me see if I have a, yeah. So let's bring this over. So say I want to build this out right now, right? You will probably be more than likely and tempted to go into DigitalOcean and create 2 load balancers, 4 web servers. You'll probably create 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 servers, right? Fairly simple, right? To create those 12 servers. Let's do it, right? Let's create a droplet. And we're gonna lead, let's do CentOS and let's do the latest. We're gonna do the cheap one, $5. But keep in mind, you know, if you're doing this inside of this console, your web servers are not gonna be the same size as your databases. So immediately right there, that means I can't do 12 at one time. That means I'm gonna have to do 4 here. I need to figure out some sizing here, and I need to figure out some sizing here and here. So that immediately goes out the window. So now that means I got some extra clicking to do, but that's no big deal. So let's go with 4 web servers on the front. We'll put it in 3. Just as easy to do a password. You can uh, put in your password that you want. And then you can come down here and say, well, increase. You put down the 4 droplets. You'll name those droplets. And then you'll enable backup for each one of those droplets. You can assign a tag and then create your droplet. But now I have to come back in here again and I have to do this again because for my infrastructure, what I see is I still need to go back through and create 2 load balancers. I need to get them talking to each other. I need to create this database, these 4 machines, so I can have a database cluster, 2 HA proxies, and then 2 backups. So I can take the time and do this, but guess what? I don't have because I'm working with another team member. Guess what my other team member doesn't have? They don't know the state of of this particular deployment. They don't know where I deployed it to. They don't have any type of, if they need to change it from being in New York NYC 3 to SFO 3, and these are the data centers for DigitalOcean. If I need to change that, guess what? They got to stop what they're doing. They got to destroy it, and then they got to go back in and create it again. But guess what? I don't come to work to 10 o'clock the next day, and if they didn't take notes and let me know that they did it, I'm gonna come in and create that stuff. Or I'm gonna log in and see that it's created, maybe not, depending on how the account is set up. So you leave a lot of room for drift, you leave a lot of room for complications, and you leave a lot of room for your cost to go up as well. So that's the whole idea behind setting up your infrastructure as code and using something like GitLab or GitHub for version control, so you can keep up with that and keep in a state file. So that's what we got here. And also, say I want to have that same diagram. I want to have that same setup in on-prem, right? I want to deploy this on-prem. I can't afford to not have my infrastructure codified when I'm doing that. So that's a unique advantage I'm gaining there. All right. So um, we went through that. We went through that. All right. They went through the use cases. So now let's look at this. They're saying Terraform versus other software. So the other software we were talking about, remember we were talking about cloud formation and heat. So let's look at Chef and Puppet. And before we dive off into that, this is going to sum it up for you. Terraform versus Ansible versus Puppet. It's a good one there. All right. What is Terraform? Why Terraform? Blah, 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 blah. I'm looking for the diagram. Pay me no mind as I go fast. Here we go. Okay. So going back to that roadmap where we were talking about configuration management, Ansible, Chef, Salt, and Puppet, and then Terraform. So Ansible actually has a way to save state, but not natively. It's something that you have to, it's an add-on. Chef and Salt and Puppet, no. But Terraform, yes. So let's go to this diagram here. All right, so Chef, what they're telling you right here when you're looking at these right here, um, it should be saying what language it's written in, but they don't have it in here. So let's talk about it. Chef is written in Ruby, Puppet is written in Ruby, Ansible is written in Python. I'm not sure what Cloud Formation is written in. I know Terraform has their own language, or I should say HashiCorp has their own language. Tara, what is that?
It's HashiCorp language.
Hey, boom. Boy, she's on the road tonight. All right, so yeah, HCL, HashiCorp language. And JSON, really what they're saying right here, that's not true. Really what they're saying right here, these are the outputs that they're actually, well, this is what you write in. You're writing in a YAML file. You use JSON to write CloudFormation code, and you use Terraform to write this, and then Ruby, and then Chef. But what I was saying was these what code are they written in? Chef is written in Ruby, Puppet is written in Ruby, and Ansible is written in Python. So underneath the layers, that's what the code is. And then they say, well, what is it? Again, configuration management here, and then orchestration of the kind of like controlling what you're going to do out on that cloud. And then they also talk about what your infrastructure looks like. Is it mutable or immutable? Mutable sounds just like it sounds. I can manipulate it. Immutable is just like it sounds. I cannot manipulate. When we're talking about the language, so when they say this, they're actually referring to uh, how it works. So with CloudFormation and Terraform, I declare, in other words, I write down or I declare what I want to see inside of my cloud. I come in here and I declare I want this to be X, Y, and Z. That doesn't necessarily mean the way I have it written out in here doesn't necessarily mean that's the order it's going to get deployed. So when you're talking about Chef, Puppet, and Ansible, you see Chef is procedural, right? and Puppet is declarative cloud formation, and so is Terraform. So that's an interview question. Someone will ask you that. So be prepared for that. The other thing is, how do these actual applications work? Well, for Chef, you have to have an agent on a system, and then there's some server that's out there that it talks to in order to manipulate and do what it needs to do. Same thing with Puppet. But with Ansible and CloudFormation and Terraform, you don't have an additional step to do. That's why you downloaded that binary, you're done. If you wanted to set up Puppet, you would have to set up a Puppet server, unless you use Puppet Bolt. You would have to set up a Puppet server and then an agent in order to communicate, and then the Puppet server will act upon where the agent is deployed. The same thing with Chef. And so in here, they're saying, hey, well, where can these be used? They can be used in all clouds. As you can see, not CloudFormation, it's only used in AWS, Terraform everywhere. And then execution control, again, see the Chef server, the Puppet master, no controller, just your Ansible file, your Ansible files. You're using SSH anyway, and then CloudFormation, no. And Terraform execution control would be just you deploying, no agent there. And then they also talk about state management, which we discussed earlier. So are there any questions? I'll send you this link so you all can refer back to it whenever you need to. All right. So that took care of this and this. They talk about heat in here. I have not played with heat in a very long time. And Boto, that's your Python. Uh, there's a Boto, there's an AWS library for that to talk to AWS via Python scripts. Fog, I'm not familiar with. Custom solutions. Let's see, what do they have under here? I don't see anything that stands out. All right, so example configurations. All right, so now they get into a two-tier architecture, some example code, and let's see if they got a diagram. Nope. All right, so main.tf. Let's read through this um and I'll show you how to read through this. And then we'll go back and do some we'll look at some code that I had written and we'll talk through it. AWS instance. D, can you post that last link? All right, so here and here. All right, so let's talk about this. Any questions so far before I get into it? Is everybody able to keep up, understand the flow? Okay, cool. All right. So whenever you want to use, let's go up here first. Whenever you want to use Terraform, and you say you want to use it with, let's for right now, let's stick with DigitalOcean or AWS or Azure. Well, we have what we call Terraform providers, right? And so these providers are, if you click on Terraform and you went to providers, here's all the providers that they have. And basically, the way Terraform is working is Terraform is making API calls to uh, your particular instance, your particular cloud in order to do a deployment. But they're just API calls. So let's look at DigitalOcean first, because that's the one we have open. Now, what they're telling you is in order for you to talk to DigitalOcean, you're going to need to get the proper credentials. And those credentials are API credentials. So you would have to log into DigitalOcean. You have to come down here. You have to get an API, as you can see over here to the left, and generate a new token, and then it will give you an API, a token that you'll have to use in order to talk to DigitalOcean. Those are your credentials. If you're using AWS, AWS needs AWS, your access key and your secret ID in order to communicate via CLI, in order to talk to AWS. So every cloud has their own way to communicate, uh, and you have to figure out. You have to log in and figure out what that is. And 9 times out of 10 is Terraform will tell you, but 9 times out of 10 is either a token or some type of access keys or something of that nature in order to talk to um, their particular cloud provider. All right. Um, so let's go back. I showed you DigitalOcean, and you know you need a token. And let's go up here to AWS so you can see what they need. So up here in AWS, you have to have some type of authentication, right? And now the authentication, you can get your AWS keys and set them as environment variables, your access key, and your secret ID, or their shared credentials or EC2 role. But there's somewhere in here you need to provide it with what region you're deploying to, and then your access key and your secret key. That's how AWS talks to uh, that's how Terraform uses AWS to information in order to talk back and forth to AWS CLI, or I mean API. And then here they're showing you when they say appear environment variables, they're showing you how you would do that if you were setting up environment variables. And then again, if you're doing shared credentials out somewhere in some user space where you got shared credentials, or it could be a EC2 role, and then they have that set up. So that's a multiple ways that you could talk to uh, AWS with using Terraform. All right. So now let's go back over here. So one of the things that you want to do, let's see, where's that Terraform file that we had? I'm missing it. It's cloud formation. Oh, here we go, right here. All right. So here, if you scroll down, the first thing I do when I need to find out what the provider needs is I scroll down and I say, well, what's required when I'm making something? So I know right now I need an AMI. These things are optional. Um, and then you have see optional, optional, optional. I think the VPC you need. Let's look over here and see. Let's go here and do. Oh, it's not. Hold on 1 second.
Our
Yeah.
mother
So
does this every Wednesday.
yes, like clockwork. All right, required. All right, so we got AMI. We got a total of 6. We got AMI. We got instant type. We got device name, and we got device index. Oh, that may fall just under device under network interface. When you're doing a network interface, you need those 2 things. And then if you're using metadata, you'll need that. So, but if you scroll up here, back up to the top, you see that you have the provider, and inside of AWS, these are the regions. This is one of the regions that you'll provide. You could deploy in Africa. You could deploy in US East 1, US East 2. You could deploy in West, whatever. But right here, this is where it starts to get really funky. So I'm going to explain this first, and then I'll come back up here and I'll explain this. So I want to deploy an EC2 instance out in AWS. It's telling me two things. It told me that I need my AMI, right? And it also told me that I need my instance type. So what you see here, and I'm gonna show you this. You see where I've declared my AMI and I've gave it data, AWS, AMI, Ubuntu, and the ID. And then my instance types. And if you're familiar with AWS, you get the instance types from their stuff. Actually, you can query and get those instance types. But if you don't know, um, here we go. So you can look here and you can come, you see you got A1s, you got T3s, you got T3A, T2, M6G, M5, M5A, M59. So you can put different instance types down, and they give you what goes with what: general purpose, compute optimized, memory optimized, accelerated computing. You'll pick out what you need, and based upon what your application is doing. So that's where that comes from. All right. And then what they do is they tag it. So if you ever played with AWS and you need to go back into your console, and then you want to tag it with like, hey, this is my Hello World application that is in production or that is in development, you can tag it with what you want. So let's explain some things here. So one of the things that you see a resource right here, and then up here you see data. So the major difference between the two is I am declaring that I want to create an AWS instance by the name of web. I want you to use an AMI that already exists. And this, how do I know that this already exists? Because you're using this word right here, data. Between resource and data, that's the major difference. Resource saying I'm declaring you to create me something. Data is saying I already exist. So what you're saying is, and you can see that up here, data, AWS, AMI, Ubuntu. This is already in existence. I want the latest AMI from Ubuntu. And how do I want you to grab that information? I want you to filter out on the name, and the values of that name is here. And also, I want you to filter out on the virtualization type, and I want it to be HVM, and I want the owner, meaning who created. The owner is who owns that, which is no more than like the person who created, or the account that created this particular, in this case, this particular Ubuntu instance. And I want you to return me the ID of that instance. Once you get that information, create me a T2 micro inside of AWS, and then tag it with Hello World. Now, how do I know that it's going to return me this ID? I know that because if I scroll down here, these are the things that the resource, keyword, the resource is going to take in as in a declarative format. So I could put in availability zone. I can put in the host ID, the the CPU core count. I can put all that information in, the key name that should be associated with that. But if I keep going down to the bottom, boom, 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 the attribute reference is what I want. So everything above attribute reference is what I can use with the resource. Everything below here is what I'm going to be returned, kind of like you would do in coding if you're using headers and getters. I'm going to create something and then I'm going to return something. So this is the return. And I want to return that instance ID. I could return the key name. I could return the public IP. I could return the private IP. But I'm also, scroll back up, all the way back up here. But I'm also saying that I want you just to return me this ID. But I could also return, and the syntax would be AWS dot web dot private IP. Return that information to me of what it is. And that's what you're doing here. So before, when we had our architecture here, I want to go out to AWS and I wanted to create 4 of these instances based upon an image that's already made, that I may have already set up some special things that I need, such as tools or the latest and greatest secured image or so forth. I can take that image so I don't have to start from scratch and deploy my 4 front end instances that I needed out there. And then I could also make an adjustment and say, well, I don't want it in this VPC. I want it in another VPC, or I want some security groups added and created to it. I can manipulate that. All this code. And then once I have that written up, I'm going to check it into my GitLab server. And once I get that checked into my GitLab server, I could then hit push to do what I needed to do. So this is some code that I had written up inside of uh, here for DigitalOcean. And basically all I did here was the 4 steps for deploying code for Terraform. And this where it starts talking about it here. So the first thing you do, and I'll recap that, is you initialize you initialize your code. So basically, the initialization means go out to HashiCorp and pull in the providers that I need. In one case, I'm showing you AWS. In another case, I'm showing you DigitalOcean. All right. And it's going to pull down into a directory that information. And let me see if it's captured in here. So here it is right here. So Terraform initialize. I'm checking the provider plugins. I'm downloading the plugin and I'm telling it I'm using DigitalOcean, because if you look back up here where we say provider, in this particular case, the provider is AWS. The project we're looking at is DigitalOcean. So I'm saying we're using DigitalOcean as a provider. And guess what? I'm not telling you what version to use. So use the latest version of that particular provider. And once you have that version installed, pull down, I want you to it automatically creates a state for me. Well, that state, again, if I have multiple people working on this project, that state needs to be something that's shared amongst the team. So it won't sit on my desktop. Here's the one thing about the state file. If somebody ever gets a hold to your state file, they got access to your entire infrastructure. So you need to store it somewhere secure where no one has access to it outside of your team. So you have to make sure that's secure. And then the next thing we do, and they tell you this in here, we need to validate. So what the validate does is it's going to check for any type of errors, any type of things that we know the syntax is all off. You need to fix that. That's what the validation does. All right. So once we have validated our code, we're going to plan. All right. So Terraform, and what it does is it says, okay, you initialized it. We got a state. We know where that's existing at. We have our latest providers. And we're going to validate your syntax and everything looks correct. And now what we're going to do is we're going to go out. And in our case, for this one that we're looking at, we're going to go talk to DigitalOcean. And we're going to say, because remember, I use my token because I can talk to DigitalOcean via my token. I have to get access to talk. Remember, I need some type of API for DigitalOcean. And if I'm using AWS, it's those shared keys, the access key and the secret key. I'm saying I have a token and I'm talking to DigitalOcean and I'm just going to plan something. In other words, I've written my actual my documentation. I've declared what I want my infrastructure to look like, and I'm just going to plan do a Terraform plan to go out and see if I can create these things. So if you look through here, there is a Terraform plan. And I put this out into a file called infrastructure plan file. And so in here it's saying, okay, well, I'm gonna go and execute this plan, and I'm going to create a DigitalOcean database cluster. I am then the engine is MySQL. I've declared all this as code. Um, the region I'm deploying in, the size, I've tagged it, right? And then also I'm going on and creating more droplets, some domains, another droplet, because I think I declared 4 droplets here from based upon this diagram, these 4 droplets. And then this database cluster gets declared. These 2 load balancers get created. This HA proxy, just the infrastructure, no configuration, gets created, and then I can go back and inside of here and start applying what I want to how I want those machines to be configured. So that's what all this code is. So how does that code get generated? That's just the plan. So that code lives here. Well, let's back up. So in here, I'm doing just some stuff. So this is what we call YAML. And this is what GitLab, and I think you saw that with Ansible on that chart. Here's what a YAML file looks like. YAML is space sensitive. So if you see these indents, know that these indents are 3 spaces, as you can see. That's how sensitive. If you go over 4, it won't work. If you go over 5, it won't work. It has to be exactly 3. So what you see here is a Docker container that I'm pulling down that contains my tools. Remember, I'm no longer doing this from a console where I can log in and just go in here and just point and click. No, I am now, my Docker container is now becoming me. It's going to do the things that I want it to do as if I was sitting inside of the machine and doing something. Like, hey, I'm talking to DigitalOcean and AWS, and I want you to, take my magic wand and spin up 4 machines. That's what this is. All right. So let's go back over here. So I have tools in here. So tools that I need inside of this Docker container are Terraform. I may need Ansible. And because I need Ansible, that means I need Python. If I had Puppet, I would need Ruby. If I had Chef, I would need Ruby. If I have, Puppet, Ansible, Chef, there was something else. It was another configuration tool. I forget. Salt. Oh no, I think it's Salt written in Ruby. I can't remember. Had to check that one. But I would need to know, I would need to have those tools inside of here if I'm going to use it later on in what we call pipelines. So right now, I only got one stage, and this one stage is just to create a droplet. So as you can see here, I did a Terraform initialize. Remember, I'm grabbing providers, and I'm grabbing the creating the state, and then I'm saying right here, I'm exporting my token. This is when I export my token. I was just grabbing and playing around here, and then I want to validate, and then I want to do a Terraform plan, and the last step would be a Terraform apply. So with the Terraform apply, if I add that step in here, it's actually going to go out to DigitalOcean and create those things. Nothing happens until you hit and apply. All the plan does, it says, I'm planning on deploying this. Does this look correct? And then when you go to apply, you can auto approve or you can type in yes, but nothing doesn't happen until you hit and apply. And once you hit and apply, then that's when the magic happens. So that's why you saw in here, inside of this step here, you saw that it told you what was going to be created. Let me scroll back up. It said these things will be created. Another thing that you should notice on this screen is you see these green pluses. What do those things mean? Well, it looks like like you think it would. A plus meaning I'm going to create. If it was a minus, that means I'm going to take that away, meaning I'm going to destroy that. If it is what we called a tilde, that means we're probably just gonna leave that there, but we're gonna replace it. And let me see if I can find that on the study guide. Let me see. It may be under plan. Let's see if they have it. No, they don't have it. Let me see if I can see it. Any questions so far? No? Everybody understood what I was talking about?
Latoya says she's just taking it all in. I know it
Okay.
could be a lot.
All right, hold on. I'm looking for it. I don't see it.
Everybody's like, yeah, they're taking it all in.
Okay, that's cool. All right, I was looking for it. I am going to try to find that and send that to everybody. I'll post that in Slack. But that's what they mean. The plus sign is for, let me see if I can, I know I have some errors up here. I need to go back and fix those.
And
Yeah, it don't
China
even get
wants
the
to know what the droplets are again with DigitalOcean.
The droplets are just just like AWS, there would be EC2 instance. That's They just call them droplets inside of AWS. I mean, inside of DigitalOcean.
Are you familiar with what an
EC.
EC2 instance is, China? No. Can you let her
No.
know what that is?
Yep. Hold on one second.
For the people.
Is this one working right? For the people. I hate you.
The peoples.
Oh, that goes right there. Oh, we'll get to that. I can show you that in there. Okay, cool. All right, so EC2 is what is the foundation of what Amazon uses. So let's see, it was a good definition of EC2. It's really nothing but their VM, I guess you could say that. All right, Amazon Elastic Cloud is a web service that provides secure. That's what they call Amazon EC2. But if you look inside of Amazon, when you go to create a instance, it is called an EC2 instance. There is their definition of what a comparable to what a droplet would be, which would be comparable to you having VMware installed on your machine and having an actual virtual machine on your laptop. that would be equivalent to what an EC2 instance is. One is on-prem, the other one is in the cloud, using two different types of hypervisors, but we won't get into that.
Does everybody
But
know what
that's
a
what it
VirtualBox is?
is. Anybody ever played with VirtualBox?
Okay.
Okay.
Yes. All right. So yes, it's their VirtualBox.
Yeah. So what's so cool about that is you can take a VM that you create on your laptop and you can import that into AWS. And you can import it to AWS and export it out of AWS as long as it started out as a VM. But you cannot take a AWS instance and export it out. That's not possible. I've got to double verify that, but as far as I know, you can't export an AWS instance once you start as an instance in AWS. Just a FYI. All right. So let me see. Let's go over here. Let me go back to my main page here to talk about what we discussed. So we went through infrastructure as code. We also talked about some use cases. I figured you could probably read this blog on your own and watch that video on your own. They got a learning track. I showed you that. We talked about Terraform providers. We also talked about Terraform state. I didn't go into detail with that, but I will here in a minute. And then Terraform settings and provisioners. We looked at we didn't look at provisioners. I'll go over that real quick. And we talked about the workflow for Terraform. Write, validate, plan. Will initialize. You can write it, then you initialize it, validate it, plan, apply, destroy. Destroy sounds exactly what it sounds like. I'm destroying your infrastructure, meaning it's going bye-bye, goodbye. That's exactly what it is. Uh, so we talked about the workflow, and then we won't talk about subcommands tonight, and we won't talk about modules. Won't go get anything down here. I did go over resources and data sources. Remember, resources are things we declare that we want to do. Data sources, they already exist. I want to get information out of those to utilize them. That's what data sources are. We did not talk about none of this here. I will when we didn't do that. I touched a little bit on state. I'm gonna go back into this. This is super important for you to understand. And debugging Terraform sounds just like what it is. Debugging Terraform, I'll go over that because that's pretty quick and easy. If you want to get super detailed information about what's going on with your Terraform code and you're trying to figure out where in the world is it crashing at, do a trace. If you just want to debug, I mean, this is super uh, verbose. This is less verbose than tracing. Info is just like it sounds, just giving you info. We're gonna give some warnings, and then errors is like what it sounds. We're gonna just give you the errors. And they go into some other stuff down here, but the best way to play with these things is actually take your tf log environment variable and set it equal to trace or debug or info or warn when you do these things, and you'll understand what how many messages that you'll start rolling off your screen, and you'll be like, oh yeah, let me turn that off. We're getting ready to talk about Terraform Cloud, which gets into our state. I will not be talking about Sentinel tonight. And then we'll go over some other stuff. So let's scroll back up here. And we said managing state. And let's log in to Terraform Cloud. Somebody's not on mute.
Me, my bad.
All right, so here we go. All right, so Terraform Cloud. Remember, we were talking about state earlier, and we were talking about being on multiple teams, and we are talking about how those teams can be can be how you can utilize the state file or keep up with your state file of what's going on with your infrastructure. Well, Hashi came out with this. They came out with it last year, and they just made it. I think it's generally available like this year. But what it is it allows you to set up a connection between your GitLab account or server, and then connect to their particular uh Terraform Cloud. So what ends up happening is you'll put in some information and do some tokens and so forth and so on. And then inside of here, when I go to create a new workspace, I've connected with my GitLab VCS, and I can pick what repositories that I want to play with. So I can pick whatever repository and then, play with that repository. Right? So when I come back over here to workspaces, I'll see whatever those workspaces that I just brought in right here. And so it's trying to connect, and we'll let us do its thing here. So what ends up happening is inside my workspace, let's go to one. Yeah, this is a bad one to show. Yeah, that plan, but it's okay. So what's the advantage? So the advantage is I have a centralized location where my state is deployed to. The disadvantage can be if you don't want to share what your state looks like with a source, meaning Terraform Cloud, that may or may not be used by other people on the same machine. There's some type of security that you must adhere to. So if you're looking at it from that perspective, say I have some stuff at home and I don't want to share it with the world, you just got to remember this is shared with the world, but they have their due diligence that they must adhere to as far as security goes. All right. So inside, is this a good one? Oh no, that's not a good one. Well, yeah, that'll work. Again, here you see that being created random, blah blah blah. Boom. All right. So what I gain here is when I'm in here, I think, is this a digital? Yeah, this is Terraform Cloud. Yeah, it's not gonna come up. That's fine. So what I gain here is inside of my code here, instead of my bucket being my state file being in a S3 bucket or an object store bucket, because DigitalOcean has an object store and that object store is called spaces. Being that I want to keep my state file, I can now create this project here. I have this project here and I'll call it inside of here, and I won't check in. I could check my code into here, and then it will run everything in here. The only caveat with this is Terraform, all the files in .tf, right, for Terraform. It's going to look for inside of this workspace all those files that are in it in .tf. But because I don't have the .tf up here, I have to come back over here and tell it what directory in Terraform Cloud under that workspace to look for. So I have it set up to look for that workspace. So it'll come in here and look for this workspace right here. And then once it finds that workspace in the folder of where my Terraform code lives, it's going to come through, and I'll break this down now. It's going to come through again when you do that initialize, that provider that it's looking for. It's going to look at the vars. These are variables that I am using to describe something. So basically, I want to keep this main.tf variabilized as possible. I want this to have nothing but variables, and I want all of the variables to be defined in my vars.tf file. You want to keep that main.tf as clean as possible. And then my output is just what it says. We talked about that before. Here's what remember when I said I can return from a resource. I can return the IP, public IP, the private IP, or the ID. And then provider is nothing there. It's empty because inside my main.tf, I have a provider here. All right. So those are the four basic files. Well, really you just need main.tf, output, and vars.tf or the three basic files that you need for your Terraform code in order to create your infrastructure. And then again, like I say, you version control this. And then you can create a release of this. Say this code is done and it's doing everything that you needed to do. Your team is checked off on it. You've done the testing and so forth. You can create a release, a version control of this, and then release it as version 1 of your code. And then, once you release this as version 1, if any changes that you make, again, your state will be held out in Terraform Cloud or S3 bucket, and then you can maintain version control and the state of that infrastructure as well, in case you make any changes. Are there any questions? I'm gonna stop for now, and then you let me know.
Okay, so you're getting through. We've talked. I know I've seen this before, but you're getting through Terraform by putting your code or putting your script through GitLab. Is that what's happening here? Okay.
So basically what I have is, we can walk through that. So what I do is I come in here. Let's go to your projects. I create a new project. We'll say Wednesday, Terraform. All right. I'll make it public. You all can grab it if you want to. All right. So now it gives me a set of instructions. So what I normally do is now I come over to my machine. All right. And I'm gonna label this the same thing. You don't have to, but it's just what I do. So I know what it is. So I come in here and I say I make a directory and I drop that in there. Then I CD over to that directory. Yeah. It's nothing in there. Nothing in the directory. But it will be. But first things first is I have to do this here. I have to initialize that directory. I have to add my remote. This is adding via SSH. I'm gonna add via HTTPS. And then I'm gonna add my code, and then so forth and so on. So here's the one thing I do know. I do know my DigitalOcean token, and I do know my stuff. So let's go back to my DigitalOcean stuff here. And let's grab main.tf. And all I want is this. I'm going to come over to my directory. I'm going to make a file called main.tf. Boom. And yeah, that's fine. So let me explain what I did there. So I like to put comments in here to explain what that following code is going to do. But this code is going to create a DigitalOcean droplet The name is going to be test demo. I variabilize the image to use, the name to use, the region to use, the size, whether or not I should have backups on, monitoring, and how many I want to do, and then so forth, right? And then let's change this to class, and we'll put the company down here. We'll call it Will. All right. So because I had that main.tf there, and these should be variables as well too, I need to go get my vars file. So let's go here and let's create vars.tf. Go back over here to files, infrastructure, and vars.tf, and I can just copy that, and we're gonna insert that there. All right. We see the size. I'm not using SSH keys, so forth and so on. Boom. All right. So now I have some information in here. I'm going to go back up here to projects. We'll come over here and I'm just going to grab this as you see it here. Get init. I need to initialize get. All right. Now, because I'm using HTTPS, this is where it gets tricky. Not really. If I come here and grab that line there, I can just do get remote add. So let's go here and I'll move this up so you can see what I'm typing. So now I'm gonna do get remote add origin, and I'm just gonna add that. And so now if I do a get remote -v, we see that we have our origin going out to GitLab, right? The next thing I need to do is I'm just going to copy this here and let it do its thing. So I'm adding this information into basically memory for Git, and
Well,
then
I'm
I'm
sorry. So,
saying that.
okay.
What'd you say?
Okay. So now I'm familiar with the. I'm just trying to get my head around the get remote add.
Oh,
Piece.
because I'm telling it where to push my code to.
Get remote add. Okay,
Yeah.
to the website to get to get lab.
Yeah.
Okay.
Yeah. So get remote add
Got it.
origin. So the origin and then basically master over to GitLab. If I had another branch, then I would change branches and then I would push that code to that branch. But for now, we're just pushing everything to master. And that's why you see git push -u origin master.
I got the rest of it, but it's like get remote add. I wasn't familiar with. Okay.
Yep. So when I refresh that screen, I have now committed that code. Because we're using GitLab, GitLab needs that git runner file that we talked about earlier. And so it would need this file. Now, if I had this file, it will automatically go off and start doing exactly what I told it to do based upon those files. So I would come in here, I would set up this runner, I would set up these stages, I would do X, Y, and Z, so forth and so on. But because I have this set up really how I want to for now, which is not really what I want to do in the long run, but for now, we're just going to run with this. We have this set up, but I want to get some output, right? So let's go back to our thing here, and let's get some output. Yep. So now we're gonna create a file called output.tf. And what it's saying is, remember, I have declared in here, and I'll go back and show you. I have declared in here some Digitalocean Droplet, because remember, that's the resource provider. When you go to look at DigitalOcean, let's come over here. Let's look at DigitalOcean Droplet Terraform. When you look at DigitalOcean, they tell you what data sources that you can use. Remember, data sources are things that already exist. And then if you come down here to resources, you're declaring what you want. In this case, we want a droplet. So in here, they tell you what you need for a droplet. I need to make sure I have a required is an image, a name, a region, a size, more than what I need for AWS. And then what I can return is I can return the ID, the name, the image, the price per hour, the price monthly, the size, the this, and so forth. So in here, I am just returning we call this the splat, and then the IPv4 address, and that is found right here. So what does that splat mean, and why is that important? That splat is important because if I look inside of main.tf, I am declaring a count of 4 droplets, and that's based upon my diagram here. So I am going to deploy 4 DigitalOcean droplets by the name DigitalOcean droplet test demo, and then it's going to get tagged with demo and account index of just going to start at 0, then add 1, then add 2, then it's going to add every time. So it's going to make me some droplets with 1, 2, 3, 4 basically, and it's going to tag it for me as well, right? So that's what that is. All right, so now let's go back to saving this, but we just added something. So we have to go through our steps again. And those steps are, we need to push this code out to GitLab. So we're going to do a git add, and we want to add the current directory. And then we're going to do a git commit. This is where you have to kind of be descriptive on what you're committing. I added output.tf. All right, and then git push. And now it's going to push that code out to not DigitalOcean, but GitLab. And now when I go back up to this project, you will see that the code has been added to the project. Boom. So Terraform Cloud now comes in to play big time for us because now I'm going to create a workspace. And I'm going to add this here. I'm going to create it called, we want to see any advanced options. Yep, that's fine. Create my workspace. It's got to go back out and do its thing and pull it in. Take a minute, but that's fine. So the one other thing that we have to do for this to all actually work inside of GitLab, because I am using DigitalOcean, I need one other thing, and that is a token. So you can put the token in here, but because I'm connecting this to to Terraform Cloud, I need to come in here and I need to configure a token. So what I'm going to do is I'm going to go back over here to DigitalOcean. I'm going to grab an API. I'm going to generate a token. Generate token. I'll get rid of this token after this. We're going to copy. And then I'm going to add a variable. Let's add it here. Let's call it token. Let's go there. We're going to make that sensitive. DO token for class and say variable. All right. So we have that. If we go look at runs, did I not save it? Variables. Okay, cool. I did. All right. So now let's queue the plan. So the plan has been queued. It is now trying to do its thing. It's configuring, okay, vars token, okay, variable token. Says the root module token is not set. Oh, no problem. So now we come back over here. And this is where I don't like, this is why I put stuff inside of, this is why I put stuff inside of an export, or I use, let me show you what I'm talking about. This is why I put stuff inside of the runner, because now I can just export this token as a variable and it's encrypted. I don't have to put it inside of my file, but for now, for this class, I'll do it. All right, let's go over here. If you're not sure the syntax, we can come over here and look up how we're supposed to do the token. So let's see. Let's look up here. Digitalocean Terraform token. Let's see. I think it goes under provider. Yeah. So I would need to do that. So we're gonna come over here and we'll go back under provider, which is under my main.tf. Oh, I don't have it in here. Let's see, but that's okay. We'll put it at the top. So what we'll do now is we'll say provider, we'll do DigitalOcean, and then token, and this is horrible, don't ever do this. I don't want to do var equals that. I just do token equals. That should be okay. We get rid of the white space just in case it reads the white space. It shouldn't though. This is horrible. Boom. All right. Just like always, if we make any changes, we have to add it. And now push. So it pushed. If we come back over here, let's go to runs. We see there's this planning there. All right. What do we say? Let me make sure I'm reading the right thing. They both errored. That's awesome. You get to troubleshoot with me today. Oh, okay. Line 5. And bars at TF. We'll get rid of that because we actually have it in the main. And as you can see, when I push to GitLab, it automatically triggers the state to initialize on the back end, and Terraform Cloud is creating that state or holding that state, and then trying to actually create what I want it to. So if we come back over here to runs, you see that plan is running. And here we go, doing the state. What don't you like? A reference to a resource type must be at least one attribute. Must be need double quotes. It may need to be in double quotes. And I'll take a look at my stuff and see how I have it. It's in main. And I also have it set up to go to my email, so it's dinging in my ear. Shift $sign should get me to the end of the line. And let's double verify everything. Yeah, provider, double quote, Digitalocean token, you can var.do token, and token is required. Boom, boom. But I can set this at, let's see. Any questions on what I'm doing so far? Is everybody able to keep up? Hopefully it works. You can see it pulled in Terraform. There it go right there. All right. So I needed to be in double quotes. Okay, so it's doing the Terraform. It did the Terraform initialize. And let me scroll up here. And then see the plus it's gonna create. And that remember that splat I told you, and I had a count of 4. So it's creating a droplet named DigitalOcean Test Demo 0. It's telling you the sizes, the name, the price, so forth and so on, the size. There's 1. So I remember I had 4, so it's gonna be repetitive here. 0, 1, 2, 3. That would be 4. And then if you come down here, it's giving me a cost estimation. Nothing yet. Hadn't estimated it yet. And then I have a policy, and we'll get into this hard mandatory for Sentinel. And now when I hit confirm and apply, I'm going to say push to DO. Thanks. So now it's going to now create out in DigitalOcean my droplets. Should create it in this one because this is what I got my API from. And we'll find out. Oh, we got some errors. Let's see what we got. Oh, it's an invalid image. So I need to go back and find the image because I think I changed the image sizes for the location. But the general gist is once I go back and start, I changed the droplet image, it'll create that droplet out in DigitalOcean for me. But as you notice, it didn't find that out inside of the. It didn't find that in the plan. It only found that when it made the API call out to DigitalOcean in the apply. And you can find out what the droplet sizes are if I just come in here real quick. Let's create a droplet. It may or may not give me the name. So yeah, see, it doesn't give me the name. So what you have to do is look up API DigitalOcean. And we'll say droplet image. And they should have a list of images. Or look over here on the left hand side, images. They should give me, well, they just give me the API for all the images, but there are some image sizes like you gotta get the slug or whatnot. But we could roll with something that's over here. Is images size. They don't have one. I was looking for a way to cheat real quick. Regions. Yeah, they don't have one right here. I have to look it up. But that's how you do it. That's how you connect your GitLab server. Let me look here. That's how you connect your GitLab workspace to their image. Yeah, see, this is an image that's already existing, and that's not my image. So I would have to take my DigitalOcean CLI, I mean my DigitalOcean token, and query the CLI, query their API to get what images are available. And that's what they're saying here. List all images or list distribution images using your token using a curl command to return that information. And that's how they got that information there. Any questions? That was all I had. We can finish this up next week.